Assalamu alaikum. I want to believe all of you are doing well, and I want to wish you well as you prepare for your exam. I want to see how I can make effort to solve one questions for you, make a video that will solve a question for you per time, so that as much as I have more time, I will look at some of the questions in your past question booklet, make a video and send to you. Hopefully it is going to serve you and help you as a guide to prepare better. Now I'll make my best to explain. I'll try my best to explain as much as possible, so that if there's any area you did not understand, you are free to ask me questions on the group. So I hope we are all you will all learn from this and take advantage of these short videos that I will be sending to you from now on until your exam, inshallah. Now, the paper I have with me, as you can see, is 2018-2019 past paper. And this paper is very important because it is the first paper after the syllabus was changed last year. So I think it would be nice we start with this question paper before we go to other past question papers. Now I'm on question number 15. I'm choosing to solve extended response questions because they take more marks, 56 marks, and they require more explanation. You know, for the other one, for the MCQ, multiple choice questions, you can easily make a choice. Either it is A, B, C, or D. But in this case, if you don't know, you don't know. So it's important I start with this first. All right, so come with me as I go to solve this question. So I'm on question number 15. The questions read, the figure below shows a 20-meter long wire with a radius of 1 millimeter. When a current of 4 ampere passes through it, the potential difference between its end equals to 0.8 volts. Now, the length of the wire is 20 meters, as you can see. The radius of the wire is 1 millimeter, as you can see. And the current that flows through is 4 ampere. And finally, the potential difference across it is 0.8 volts. Now, the first question says, state three factors that affect on the resistance of the wire. Like I told you in the class, for you to state these factors, you can easily look at the formula for resistance with respect to resistivity, length, and area. You know, we have that resistance is equals to resistivity, length divided by area. Now, the question is, what are the factors that affect resistance of the wire? So from this formula, I can pick my three factors. R is my resistance. So number one is resistivity. I hope you can see my writing clearly. Number 2 is length. Length, what is that? Okay, TH, length. And finally, number 3 is area. These are three factors that affect the resistance of a wire. Another factor that is not captured in this formula, number 4, is temperature. So you can see that just this question is giving you a total mark of 3 marks. So it is easy to actually pass this exam if you study very well. Question number 15b says, calculate the resistivity of the wire. This is very interesting and easy. We'll go back to the same formula. And mark you, if you look at the back, I guess at the back of your question paper, you have a space for all the formulas. That makes it easier for you to be able to to be able to get the formulas that you need and manipulate them as much as you can. So you don't have to be confused in any way. Okay, now I have my formula now, and from the question, I was asked to calculate resistivity. Now, if I look at this formula, this is resistance, this is resistivity, this is length, and this is area. So I need to change this formula to be able to calculate my resistivity. What I do is to do a cross multiplication of R and A. You understand? Then I will have my R, which is resistance, multiplied by A is equals to resistivity multiplied by length. What I want is for resistivity to stay alone. Then I will say that my resistivity is equals to R multiplied by A divided by length. Can you see now? So now from here, I can easily calculate my resistivity. When we go back to the question, we know that there is something that looks like it is missing, but it is not missing. We can see our current, we can see our voltage, then we can see radius. Now, we did not have resistance in this question. We did not have area in this question, but we have the parameters we can use to calculate the resistance and the area. Now, what are the parameters? Let's go back to Ohm's law. I need to get another paper so that I can explain this better. Give me 1 minute, let me get another paper. No, not this. Okay, now I can use this now. Okay, now let's go to Ohm's law. What is the formula for Ohm's law? Ohm's law states that V is equal to IR. From this relationship, I can get the formula for resistance, which is R is equals to V divided by I. Do you understand? Now, if I go back to the question, my V is 0.8. Is 0.8 volts divided by, what is my I? 4. So what is the total here? Let me take my calculator. I hope you are following me and I hope you understand this explanation. So I have 0.8 divided by 4. And that is giving me 0.2. Can you see? Now I have 0.2. What is the unit for resistance? Ohm. All right. So again, if I go back, I have my radius R to be equals to 1 millimeter. Again, I have this guy in millimeter, so I change to meter. I have 1 multiplied by 10 raised to the power of negative 3 in meters. Are you following? Okay. Now, I will now take this to the formula for area A is equals to pi r squared. Pi r to the power of 2. Now, I can now say that my pi is a constant. Multiply. Now I have my radius to be this guy. 1 multiplied by 10 to the power of 3, all to the power of 2. I can put all these guys in my calculator. I have 1 multiply 10 to the power of negative 6. Negative 6 multiplied by pi. Multiplied by pi. And this is giving me 3.14 multiplied 10 to the power of negative 6. This is my area in meter squared. Now, I can have this in meter squared because I've changed my radius to meters, not in millimeter squared, but meter squared. Okay. Now, I can take these two guys and bring them back to the formula. Now, I have my resistance now from this new calculation. From here, this is my resistance, and this is my area. So I put this here. R is what? Is 0.2. Right? Multiply A is 3. Sorry, 3.14 multiply 10 to the power of negative 6. Divide. What is the length? You can see now. My length is in meters. That's why it is good I convert this radius to meters also. So I have 20 meters. What is the final answer? 0.2 multiply 3.14 multiply 10 to the power of -6. Okay, now divide by 20 is equals to what? So I have my resistivity rho to be equals to 3.14 multiply 10 to the power of 8, and this is my final answer. Now, this is my final answer. Resistivity is 3.14 multiplied 10 to the power of -8. That is my resistivity. You can see how simple this question is, and this question alone is giving you 6 marks. Now, let's look at the question once again. Now, in the classroom, you know that this is the formula you need to apply. But like I usually tell you that it is because you are in grade 12, they don't give you a direct question, so you have to think all the time. Now, you have area here, but in the question you don't have area. What you have is radius. You can calculate radius from area from your radius. Also, you need resistance. From this formula, you need resistance. Now, you don't have resistance here. What you have is current and voltage. So, from Ohm's law, as you can see, we can easily calculate our current and we can calculate our resistance from current and voltage. Then we'll put the two guys into our formula to calculate our resistivity. I hope you enjoy and understand this video. Let me know what you think about it before I make another video next time. Have a nice day. Thank you.